Hello everyone and welcome to my talk. Today I will talk about scalable distributed messaging and streaming with Apache Pulsar. So my name is Julien Jakubowski, I'm developer advocate EMEA at StreamNative, and before that I was software engineer, tech lead, manager, consultant. I have been coding for 20 years now, more than 20 years, mostly in Java and Spring. I've built several complex systems with distributed, scalable, and event-driven architecture for various industrial sectors, such as retail or finance. I live in Lille, in north of France, and I'm also one of the leaders of the several developer communities, like, for example, the Java user group of Lille. Don't hesitate to flash this QR code to reach out to me. I will be very happy to discuss with you about messaging, streaming, scalability, microservices, and such. So for those who don't know StreamNative, StreamNative is founded by the original creators of Apache Pulsar and Bookkeeper. StreamNative is one of the largest contributors to open source through Apache Pulsar, Function Mesh, Pulsar operators, or numerous Pulsar connectors also. StreamNative provides also StreamNative Cloud, so we partner with software teams worldwide to accelerate time to production and manage Pulsar at scale. And we provide a fully managed Pulsar service with enterprise features on StreamNative or customer infrastructure. And we are also the organizer of the Pulsar Summit. So I'll give you an introductory talk to Pulsar, and some of you may be new to the Pulsar community and expect to discover Pulsar through this presentation. Then welcome to this amazing community, and I hope my presentation will give you a good overview of Pulsar. Some of you may be Pulsar users already, so you may already know some things I represent. However, I hope my talk will help you promote Pulsar around you by explaining the benefits of Pulsar. So, cloud native means that Pulsar is designed for running in containerized environments and is designed to scale out. It's designed to scale horizontally. But it is not only about scalability, but it is also about elasticity. And Pulsar is both a messaging and a data streaming platform, as we will see in this presentation. So Pulsar is a messaging and streaming platform, but what is streaming? Data streaming is a process of transmitting data continuously and in real time from a source to destinations, or several sources and several destinations. The data is sent in small pieces and is processed or analyzed as received. So streaming works best when the data needs to be processed in the right order. The data, these events, they can be interlinked together, right? So they need to be processed in the right order. And this data may be persisted for a long time, but also be transformed, aggregated, or even replayed. And you may also need to read millions of billions of records very quickly and perform big catch-up reads, right? So you need throughput. So streaming platforms can handle a massive amount of data. So these platforms scale out horizontally. So typical use cases include log ingestion, and other use cases can be about real-time analytics. So you will make the right decisions based on fresh data. You won't wait for a batch process to be run tomorrow. For example, you can implement a dashboard that is updated in real time or implement fraud detection. And the most common streaming platforms are Kafka and Amazon Kinesis, and of course, Pulsar is also a great streaming platform. However, Pulsar can do more than data streaming. Sometimes we need to assign time-consuming tasks to a group of workers. So you have one producer service that needs tasks to be performed by a consumer service. And this consumer service is a worker, right? So we have several workers. And this task can take some time to process, or the consumer service can be unavailable for a couple of minutes. We don't want these events to impact the producer service. We need decoupling. So to do that, you can set up a work queue. This queue contains messages from the producers, and each of these messages is a task to be performed by consumers. You don't need to perform this task in a strict order. For example, if the task consists in pushing notification to Alice and Bob's iPhone, right? It doesn't matter if I notify Alice or Bob first, right? So a message broker manages this message queue, accepts the producer's messages, and delivers them to the consumers so they can perform the task. So there are some essential features for a message queue. For example, queues. Sometimes queue can grow faster than consumers can handle, so one expected feature is the ability to add new consumers to consume the queue faster and remove consumer when the workload decreases, right? And you need to do that very quickly. Another expectation is when a consumer is busy processing a message, you don't want to wait for the processing to be completed. The broker will deliver the next task to another consumer instance without waiting for the current task to be complete. And when the consumer fails to handle a message because, for example, because of an error or a timeout, you may need the message broker to re-deliver the message later to retry the task, right? And because of that, messages may then be consumed in a slightly different order than produced. But as we said, the order is not a very strong requirement here. So RabbitMQ and Amazon SQS match these requirements because they implement this message queue semantic. And we cannot expect these requirements from a streaming platform because these platforms are not designed for that. However, Pulsar implements both the streaming requirements and the message queuing requirements. Why not do that with Kafka then? You may think using a streaming platform to implement a work queue is a good idea. However, streaming platforms are not designed for this use case. Let's take an example with a message queue implemented as a Kafka topic. Now let's say that I need to consume the queue faster because the queue is growing too quickly. Then I need to add a new worker, a new consumer. However, with Kafka, when you need to add a new active consumer, then you need to add a new partition to the topic. So for that, you need to perform an operation on the broker side, and you will also perform a rebalance of the data across the partitions. And this can be heavy and lead to performance loss or even downtime. So you may have to anticipate and plan carefully, but Pulsar does not have this issue. Now, let's take another example. Here, one message always fails when consumed because of an invalid format, for example, or the consumer is busy processing this message for a long time. Then the remaining messages in the queue are not consumed, the queue is blocked. This is normal since there is only one consumer, one worker to consume them. Fine, so I need another consumer to consume the remaining messages. But remember, to scale out consumers, I need to add a new partition on the broker side. Okay, now I have my two partitions and my two active consumers. Great. Let's say that one message blocks the queue again. Then task from the partition 1 will be processed, which is better. But partition 0 is still blocked, so you have to wait for consumer 0 to finish before processing the remaining task in partition 0. So the problem is not really solved here. So I intended to illustrate that using a data streaming platform for message queuing is not ideal, right? These platforms are not designed for that. This is not the same use case, this is not the same semantics. So messaging is what message brokers such as, for example, RabbitMQ are designed for, and of course Pulsar. So what is great with Pulsar is that Pulsar has all of these features. Pulsar can process large data streams, just like Kafka, but Pulsar also provides message queuing features. So we can say that Pulsar is the best of both worlds, right? But how does Pulsar achieve this? There is an important concept to understand here. So the producer sends data and doesn't know about the consumers or their status, and the consumer receives data from the producer and never directly interacts with the producer. And all interactions go through Pulsar, and Pulsar handles all communication, right? So the data is sent to topics, and you can find these concepts in most messaging and streaming platforms. However, Pulsar brings another concept. This is the subscription. So Pulsar consumers declare how they want to consume messages. So for that, they connect to what we call a subscription. And this subscription specifies how consumers using this subscription will receive the topics messages. The subscription tracks which messages are consumed. And one topic can have several subscriptions at the same time. So we achieve this unified messaging and streaming use case through subscriptions. So a subscription type is a function of the consumer, and we have 4 subscription types in Pulsar. So the producer doesn't need to worry about if the use case is streaming or messaging, right? Only the consumer and the subscription will manage that. So these messages in the topic can be consumed in different ways. When you need to process the messages in the right order, you can use the exclusive mode. In this mode, you have only one consumer at the same time, and Pulsar enforces it. So you will get an error if you try to add another consumer to the same subscription. Okay, fine, but what if the consumer is down? If you can't afford to wait for this consumer to be available again, then you can use the failover mode. In that mode, when your consumer is down, then Pulsar will fall back to another one, and it will deliver the messages to this consumer. Now, with the shared mode, messages will be delivered to multiple consumers. So the subscription will deliver the messages to consumers in a round-robin fashion. So if you need to consume messages faster, you just have to add new consumers. And it is also very easy to remove consumers to save resources, right? So in this mode, messages could be processed in a slightly different order than produced. This is why the shared mode is about messaging. It works best when your consumers are workers that share the same task queue, and each message is an independent task to be performed, right? So when we are talking about these different subscription modes, we talk about how some of them are more useful in messaging domains versus streaming use cases. So failover and exclusive are very useful for streaming, and shared is useful for messaging, right? For message queue. Now, what if you need to scale your consumers to consume the messages as fast as possible, like the share mode, but you still need to process the messages in the right order? Then you will use the key shared mode. This mode is the same as the share mode, but with a very important difference. If the messages are produced with a key, then the messages that share the same key will be delivered to the same consumer. So you can process all the messages with the same key in the right order. So you can use this subscription mode for both messaging and streaming. Key shared mode is great for scaling out consumers, like the share mode, but because you have an ordering guarantee, then you can scale your streaming processing without creating new partitions, which is really great. So why choose between messaging and streaming? This is not a dilemma with Pulsar. You can do both using the same platform and the same technology. So we just saw that Pulsar can handle both messaging and streaming use cases. This is one of the key features of Pulsar. And now I want to talk about Pulsar's scalability and elasticity. And these are different because elasticity means you can grow or shrink resources quickly to adapt to workload changes. So you can save infrastructure costs by avoiding over-provisioning. Some data streaming platforms like Kafka and Pulsar can scale very well, but Pulsar is both scalable and elastic. So as I said before, you can use the shared and key shared subscriptions to enable several consumer instances to consume messages from a topic in parallel. But what if the number of messages to be consumed grows faster than the consumers can handle? Then with Pulsar, you just have to add new consumers to the shared or key-shared subscription, so you can increase the throughput by adding new consumers. But as I said earlier, you don't need to operate on the broker side. You don't need new broker nodes or partitions to do that. I mean, if the limit is not on the broker side, but only on the consumer side, right? And of course, when you have fewer messages, you may end up with underutilized consumers. So you can remove them to save infrastructure cost. And this is elasticity. So when the limit is the broker itself, you can also scale the broker horizontally without the limits other streaming platforms can have. How can you do that? Now I will explain the unique architecture of Pulsar. So this architecture is more sophisticated than other platforms, so it brings many benefits, as we will see. In Pulsar, you have the broker nodes and the bookies nodes, and the broker nodes are responsible for managing all the communication and the processing of the topics. So they are stateless. They don't store data. So a broker node deletion won't impact the data. But in contrast, the bookie nodes are responsible for storage. They have state, they store messages. The bookies are Apache Bookkeeper's node. So let's say that I need more processing power on my cluster, right? So for that, I will add more brokers. Because their state is stored in the bookkeeper tier, I can add a new broker, and that load then can be migrated to another broker. So some of the magic of Pulsar is it will take care of all the moving of connections, right? And the moving is transparent to your application. If you compare this to Kafka, then adding a new broker, I will have to manage all the movement of all the data to another broker for it to rebalance it. And there is no heavy partition rebalance here with Pulsar, and no data movement when you need to scale out brokers, when you need more processing power. Now, when we need to store more data, then we'll just add more bookies. So as soon as you add a new bookie, it's going to be eligible for getting new messages right away. It immediately becomes functional. And there is no data rebalance. So Pulsar does not have this issue when you need scalability on your data. So here is a recap of the 3 levels of horizontal scalability and the benefits compared to other streaming platforms. You may need to scale the consumer if you need to process the messages faster with more consumers, right? So how will you do that with Pulsar? We just have to add new consumers to a shared and a key shared subscription, right? And there will be no partition required, no partition rebalancing. You may need to scale the broker itself if you need to manage many topics and many client connections, so you need higher throughput. So for that, you can add new broker nodes, right, without any data movement, without any rebalancing. And this time, if you need to store more data this time, then you can add new bookie nodes, and these nodes get new messages right away, right? And of course, you can also downscale easily to save infrastructure cost. So this elasticity is why we say that Pulsar is cloud native. And to ease the use of Pulsar in a Kubernetes environment, StreamNative developed Kubernetes operators, now under a free community license. So these Kubernetes operators facilitate the deployment of Pulsar cluster on Kubernetes. So you can define your desired cluster configuration using familiar Kubernetes manifest files. This allows you for seamless scaling, and these operators also facilitate the installation of Kafka, MQP, and MQTT protocol that I will talk about a bit later. And StreamNative offers these operators under a simple and free community license. So I just presented how you can scale Pulsar with its multi-layered architecture, which is the second key feature of Pulsar. And now let's talk about the third feature, which is the durability. So topics are made of segments, so Pulsar can distribute them to separate bookies. And this is how a single topic is distributed across several data nodes. So here you have a replication factor of 3. So every segment is replicated on 3 different bookies. So if I kill one bookie, here the bookie 2, I still have all the segments in the user bookies, so I haven't lost any data. You may need to store a big amount of data and retain it for a long time depending on your use case. You'll need to read these old messages that were produced days or months ago. And with Pulsar, you can offload those messages to external storage. So instead of using our fast and expensive disk, we can rather leverage the use of third-party cloud storage systems, moving it into a more cost-effective storage tier. And this is transparent for the consumer. So if you need to replay a topic, some messages will be read from the cloud storage and others will be read from the bookie. But the consumer doesn't see this. This is transparent. Now that I presented how your data is stored by Pulsar and how you can offload it, let's talk about the multi-tenancy. Multi-tenancy allows different departments or teams within an organization to share a Pulsar cluster while keeping their data isolated. Multi-tenancy helps applications work in a shared environment by providing structure, security, and resource isolation. Resources isolation provides a better security, and sharing the same cluster also allows you to save infrastructure cost. And this is not a hack or another layer in front of Pulsar. Pulsar is designed for that. This is a built-in feature. Now I'd like to talk about another feature, which is geo-replication. It is also an amazing Pulsar feature. So geo-replication provides disaster recovery. So you have several clusters deployed in different regions or different data centers, and if you lose a region, you can recover from it. Pulsar can replicate the data to different regions automatically in a bi-directional way. And this is a built-in feature, so setting this up is basically about configuration. So now you could say, hey Julien, Pulsar has impressive features, but in my company I have an existing ecosystem. I'm sending or consuming messages with Kafka and RabbitMQ and have a bunch of microservices and I can't rewrite all of them. But I have good news for you. Pulsar has a high level of compatibility, and I will explain that right now. So as I said before, we achieved a unified streaming messaging use case through subscription. And the subscription type is function of the consumer. So the producer doesn't need to worry about if the use case is streaming, messaging, or anything else. Since it is a unified platform, those producers and consumers don't have to use the Pulsar protocol. So you can have producers that are using the Kafka protocol and producing to a Pulsar topic, and you don't have to change the code because Pulsar has a compatibility layer, a protocol adapter that is compatible with Kafka. That's the same for RabbitMQ and MQTT. And you can do the same with consumers. You can make them believe they are consuming a Kafka topic or a RabbitMQ message queue, but they are consuming a Pulsar topic. And the magic is that all of that works at the same time with the same topics. So you can integrate Kafka-compatible apps with RabbitMQ-compatible apps with Pulsar. To write current application, you have many Pulsar client libraries available, so you will surely find one for your favorite language. So you have a huge ecosystem. And don't hesitate to check out hub.streamnative.io, where you'll find a wide ecosystem of connectors, libraries, protocol handlers, etc. Pulsar has also a great open source community. All of these features I presented are available in open source, so if you download Pulsar, you'll have all of them. This is great because you don't depend on a specific vendor. You're free to call a vendor to provide a Pulsar as a service like StreamNative, or you can manage a Pulsar cluster by yourself. There is no vendor lock-in. So here is a quick recap. So Pulsar is a unified messaging and streaming platform handling both patterns, both semantics at the same time, so you can have only one platform to manage. Pulsar is doing great at both scaling and being elastic, and it provides 3 levels of elasticity. Pulsar ensures the durability of the data and can offload to external cheap and unlimited storage to save cost. Pulsar can also provide multi-tenancy. Pulsar has geo-replication built in, which is great for disaster recovery. Pulsar is compatible with your application portfolio. And all these great features are available as open source, so you have no vendor lock-in. Alright, so thank you very much. I hope you enjoyed this presentation, and now I will be very happy to answer any question. You can also flash this QR code so you can reach out to me and get more resources about Pulsar. So thank you very much, and now time for questions.